Hi, so I'm going to start this video trying to integrate this without thinking it too much, because I could find the antiderivative of 1 over x squared, which is just negative 1 over x, right? Because the derivative of negative 1 over x would give me positive 1 over x squared. And I would evaluate this at the endpoint, which is negative 1 and 1. So I'm going to do this very carefully. I'm going to plug in the 1 first. So I have a negative 1 over 1, and then I'm evaluating at the lower point, so I have a negative coming from the evaluation into the lower point. But then I'm going to evaluate it, so I get, let me put this blue, so I'm evaluating a negative 1 over, and I have a negative in the bottom, so it's a negative. I have too many negatives here, but I'm writing them all to see what is happening. Okay, so this is the negative that we come up from evaluating at f of b minus f of a. This is the negative that I get from the formula, from my function. This is this negative. Okay, and the last thing, this negative, is because I'm evaluating at negative 1. Okay, so you have too many negatives here, but this ends up being negative 1 minus a 1. Right, I have 3 negatives here, so it becomes negative 1. So I get negative 2. So it sounds like we could move on and think this makes sense and just move to the next problem. But this actually makes no sense, because if you think about the graph of 1 over x squared, and what is it that we're finding, 1 over x squared looks like this. So, sorry, it should be symmetric around the y-axis. And whatever it is we're finding between negative 1 and 1, we're trying to find, or estimate, sorry, this should look symmetric again. We're trying to estimate this area. So it looks something like this. That's a better picture. First of all, this area could be infinite. It could be finite if it converges, but there's no way I can get negative 2, because it's positive. So whatever I did right here is wrong. And why is it wrong? Well, precisely because we have this vertical asymptote, and we cannot do it this way. So this is totally wrong. We cannot do that, so we have to start over again. So how do we approach this integral? Well, I need to do it as the integral from negative 1 to 0, that's where I have my asymptote, 1 over x squared dx, plus the integral from 0 to 1 of 1 over x squared dx. Now I'm going to try to find only one of these areas, right, separately, and then do the other area separately. If they converge, then both of them have to converge. If one of them diverges, the whole thing diverges. And I need to approach this as a limit, right? So I'll do that in a minute. But my point now is that, well, this is a even function, so I'm going to evaluate one of them only. Let's grab this one, and I'm going to do integral from 0 to 1 of 1 over x squared. And I need to approach this as an improper integral, so I'm really doing the limit when a certain number goes to 0 from the right, I'm going to 0 from the right, I'm going here, from n to 1, 1 over x squared dx. So I need to approach this as a limit, and now I can say, okay, so this is, I really should be doing the limit when that number goes to 0 from the right. I did integrate this correctly, negative 1 over x, from n to 1. If I do this now, I get negative 1, sorry, I need to write the limit, still evaluating this limit, when n goes to 0 from the right, negative 1 over n, and then plus 1 over 1. I have these backwards. Yes, I have them backwards. So it's negative 1 over 1 and plus 1 over n. Right, I'm evaluating at the first point. I didn't do it carefully now, and I got them backwards. So evaluating this point first, and then evaluating this point second. And it's a minus, so it's a plus here because of this minus that I have right here. Okay, and now as the limit, this number is -1, it's not going to change it, but this, now look at the function of 1 over x, and I find the limit when x approaches 0 from the right, so this is infinity. So actually this integral diverges. I only proved that this area, the red or the pink area, is infinity, it does not converge. So with more reason, the other area doesn't converge because it's symmetric, or if you add them, it wouldn't converge. So when we do problems like this, we have to be very careful. Is your function defined everywhere in the domain of integration? If it's not, we need to split it up like 2 integrals, cutting it off where it's not defined, and approach each one of these as an improper integral. So be careful with those problems, and this is a good example to know that you have to clear it off.